In each coming together, every time that two beings unite, get close, brush against each other, whether two plants, two animals, one animal and a plant, an animal and a human being with a human being, life is transmitted. A life discovered barely 50 years ago. A different form of life. For years, physicists claimed that this was material for them to study. They were inert beings, simple crystals in nature. But no. Scientists who characterized the life of the invisible discovered that in the deepest part of a rare and simple structure, there beats life. But what kind of life? They're everywhere. Millions and millions of beings that surround us and invade us. Active and inert at the same time, hidden in nature or latent in our own bodies. Leaping between species, evolving, threshing the earth. We hereby inform you of the possible appearance of an outbreak of hemorrhagic fever in Angola. The Marburg virus is suspected. Never before had the Marburg virus appeared in the west of Africa. The news led to an urgent meeting of epidemiologists, virologists, specialists in infectious diseases. This is the GOARN, the center of the World Health Organization responsible for keeping watch and responding to the appearance of epidemic outbreaks in any part of the world. A screen displays the countries suspected of suffering an outbreak and the possible infectious agent causing this. If a virus is not controlled, it can spread throughout the world. But there is no international law that obliges a country to declare that it is suffering an outbreak. They tend to hide this. What the World Health Organization often receives are pure and simple rumors. The specialists discuss whether or not these are credible, whether or not they have to press the alarm button.
About half of the information that comes into this room are these rumors from media reports. We also get emails from visitors, travelers in different nations. We get official reports and from the countries themselves, the ministries of health, and we also get unofficial reports from NGOs.
The appearance of the Marburg virus in Angola requires immediate international intervention. The country does not have the capacity to control the outbreak. There is the risk that it will spread beyond its borders. The WHO has to act, but this Ministry for World Health is forced to ask for money so as to be able to intervene.
This operation doesn't have a reservoir of money that it can draw on to finance an outbreak from beginning to end. And so we had to send out a request to donor countries asking for their support.
Once on the ground, they have to find all the possible patients, isolate them to slow down the spread of the disease, and to be able to eradicate the virus. But they are in hiding. They are scared of the whites who come so menacingly dressed. Nobody explains anything to them. There is a rumor that the whites perform rites, that once they enter the hospital, they will never return home. And nobody has returned home. The government intervenes. It demands that the population, under threat of prison, report suspected sick persons among their neighbors and family. The law is as questionable as it is effective. The outbreak started in a hospital. The virus was being transmitted from children to mothers, from mothers to other children, brothers, fathers, neighbors infected by simple contact, doctors and nurses as well. But there is no treatment to cure infection by the Marburg virus. And in this outbreak, the virus displayed impressive deadliness. 99% of the patients died. An NGO, Doctors Without Borders, which was operating in the area, took on the task of treating the patients in the same hospital in which the outbreak arose.
The hospital was an extremely unsafe place. It was the hospital in which most of the contaminated cases recorded arose. There was a mass of deaths among the health personnel, the nursing personnel working in the hospital. Up to 16 nurses and doctors died in this hospital because of Marburg. The part we had to install was an isolation unit. An isolation unit means you need a lot of personnel. You need a very intensive treatment for your personnel so that they can interiorize a heap of rituals and objectives so as to prevent transmission. Rituals that appear simple to us, such as washing hands, how to dress, how to undress, what to do with disposable materials, how to touch or not touch patients. Of course we're afraid. Fear, first of all, is healthy. It keeps you on a state of alert. That is why you are only here for 6 weeks, because then you stop being afraid. And out goes that little light that tells you that you are not doing things right. All of us working there had it. Even people who have already gone to other epidemics, who have already worked, who are experienced. But if you don't have it, you are irresponsible because you don't know where you are going. My colleagues who were working in the nearby villages were working with gloves and nothing more. And the cases, well, one always suspected that there would be a case. Well, they were also afraid, which is logical. Knowing how many red blotches you have on your skin because this is a sign of hemorrhage. Well, I have never stopped to count how many spots I had, but here we've all looked the next day to see if something new had appeared or not. We've all done it, but nobody says anything so as not to worry.
With the hospital converted into a secure place, the NGO allowed patients to receive visits from their families. But the fear of the virus was already widespread, and very few dared to cross the barrier. This girl appeared one day, alone. She asked to see a patient. She accepted the rules. Silent, she swallowed her fear and went in to see him. His pain paralyzed him. The enormous pain provoked by the hemorrhagic fever, the inevitable surrender to the illness, desolation, total dependence on others. And it is precisely now when a patient needs the most care, the moment at which the illness becomes most contagious. The virus needs closeness to be able to transmit itself through bodily fluids. A simple drop of sweat is enough. The Angola outbreak caused the death of more than 350 people. Half of them were children. The samples of the Marburg virus collected in Angola are here now, in the Center for Disease Control and Prevention in Atlanta, held under strict biological security conditions. This suit allows the researchers to breathe virus-free air because of the positive pressure maintained inside it and the possibility for permanent connection to a source of clean air. Sealed areas, large-scale sterilization systems, absolute air filters, negative air pressure. They all allow this building to house the greatest known samples of highly contagious viruses without these being able to escape to the exterior. The Marburg virus shares space with other agents that provoke hemorrhagic fever, such as the Ebola or the Rift Valley viruses.
The main kinds of viruses that we work in this facility are ones which are high hazard, so they're usually associated with high case fatality in human infections, and also that they're infectious by aerosol, so it makes them quite dangerous to try to manipulate in the lab environments. And for most of these viruses, no available vaccine and no efficacious treatment. So if you get infected, there's not an awful lot we can do to try to protect the individuals that get infected. So these are the sorts of reasons why the viruses will go into this kind of facility.
More than 30 new diseases were detected in the final decades of the 20th century. Most of them are associated with a virus. Among these are those caused by the Marburg virus, its close relative the Ebola virus, or HIV, which causes AIDS. The origin of many of these continues to be a great enigma.
Virtually all of the emerging diseases that we've seen in recent years are what they call zoonotic agents. So they're actually in animal reservoirs out there in nature, and what we see them is jumping over from animals into the human population and then causing these large high fatality disease outbreaks. But the big problem with the filoviruses, Ebola and Marburg viruses, are that we don't know what the reservoir is. So we've actually tried in several of these previous outbreaks to do an ecological study, collect lots of specimens from animals and insects, and see whether we can find what's the reservoir. Because if we knew what the reservoir was, then we would know where the virus was in nature, and then we could also put in place risk reduction recommendations to try to prevent people getting these infections from the source of the virus. But so far we've had a complete failure in that area. So that's one of the big enigmas. We've learned a lot about these viruses over the past 40 or 50 years, but we still don't know where they're hiding out in nature.
Hemorrhagic fever, flu, measles, yellow fever, dengue fever. All these serious and sometimes fatal illnesses, capable of ruining a country's economy, of closing its borders, are provoked by these minute beings, all of different shapes, all strange. Nobody had seen them until a few decades ago. Nobody had even imagined what they looked like. That was until somebody had a brilliant idea, applying a tool designed for physics, the electron microscope, to the living world of biology. The power of this technology to increase the size by millions made it possible for the first time in the 1950s to see some extremely small geometric structures determined on reproducing themselves exactly.
They were practically images of shadows. Some small grains appeared on a diffused background. Some small grains. But naturally, as these were all the same, then obviously this was the virus.
With these images came the confirmation expected by many scientists. There were other infectious agents, different from bacteria, capable of producing illnesses that are transmitted. But also, the viruses were thousands of times smaller and apparently simpler. How could they be so contagious? How could they multiply with the best known efficacy? How could they provoke serious illness barely a few hours after infection?
It was seen that viruses were using something that gave symmetry, that this was what allowed them, with very little genetic information, to construct very complicated structures, very large and very complicated. And it was precisely this that was a very important conceptual change, the construction of vehicles for transferring genetic information that are extremely complex from the structural point of view and extremely effective, as demonstrated by the way they infect us and how they are capable of conveying diseases and provoking authentic cataclysms.
Today, the data supplied by electron microscopes, in combination with complex mathematical models, allows us to see very different images. Now the viruses can be shown in 3 dimensions. The best image of a virus might well have stopped there. But the instinct for eternal research, of raising a new question for an old response, led this scientist to embark on a unique adventure, getting to see the viruses in their most profound dimension, their atomic composition, their structure through the atoms they comprise. Michael Rossmann left his native Germany to work in the United States. Waiting for him in Ithaca was one of the experiments for which he is now known throughout the world. His idea was to apply to viruses the complex technology known as X-ray diffraction in the equipment known as the synchrotron. Following various attempts, small failures, but without losing his conviction, in the spring of 1984, Michael Rossmann obtained the first atomic image of a virus in all history.
And there was a big thunderstorm, and thunderstorms aren't very good things for a synchrotron. So the synchrotron went down, and the instrument we were using, the camera, crashed. And during the time that the camera was being repaired and the synchrotron was being repaired, I did some thinking about what was wrong with our previous technology. And so when the camera was repaired and the synchrotron was repaired, we did all the things which we thought about, and then we took a picture.
In the most intimate photographs, that of the atomic structure of viruses, the great strategy that makes them so effective appears: symmetry.
And it was a fantastic picture.
The cloud of infinite points, the virus atoms, appear magically and inexplicably ordered. Scientists around the world apply the technology developed by Rossmann to obtain an atomic image for the viruses with which they work. This was the first photo obtained here in the synchrotron, known as CHESS. CHESS, the installation that makes it possible to photograph the most minute infectious agent in nature, is paradoxically the size of a football field. Inside, one loses the notion of space and time. One could be working in a space station. The researchers come here with crystals made of viruses. Each crystal contains hundreds of thousands of the same type of virus, perfectly ordered. These are crystals that are identical to those that form the minerals found in many rocks. In the CHESS synchrotron, Richard Gillian is the specialist in taking atomic photographs of viruses.
So it takes a very, very steady hand, but I've got one right here.
The virus crystals prepared by scientists in laboratories throughout the world reach his hands.
The trick is to mount it quickly. This is a very, very cold stream of nitrogen gas that freezes the sample instantly so that no ice forms. It's like a glass.
The crystal is already prepared for receiving a powerful X-ray beam.
Okay. Now is the moment that many researchers have been waiting for. They've spent a long time growing their crystals. They've mounted it on the beam line. And in fact, you can see one right here. It's that blue area is an actual crystal of a biological molecule. But before we can take a snapshot, we have to close the radiation area, which I'm going to do right now. That was a very heavy lead door that we have to put in place to protect us from the extremely bright X-rays that we're about to use. So I've placed the crosshairs right on the protein crystal. I can take a snapshot of it. And within a few minutes, we get a pattern of spots. Unlike an ordinary digital camera where you have a lens and you can focus on an image, with X-rays we have no lenses. So instead, we have to shine an X-ray, look at the scattered particles, and we get a bunch of dots on the screen.
When the X-ray hits the virus sample, it is diffracted into thousands of small X-rays. Each beam produces a point on the screen that receives the image. Each one of these points comes from a virus atom. That is how the virus is portrayed, atom by atom.
Usually they bring many, many crystals. The virus crystallographers may be hundreds of crystals to get a single set of data from which they can extract a picture of the molecule. But we also are lucky sometimes. We put one crystal on, do 180, and we're done, and it works. It's very much an art as much as a science.
Having obtained this image of points, what the scientists really have is a tangled web of data. It requires laborious mathematical analysis, computers, a lot of people working several years to decode this web. Years to obtain a much more recognizable image of a virus such as this one. But it is difficult to imagine what scientists see in these webs of color. Why so much investment? Why so much effort? What they have achieved with an image like this is to undress a virus and extract its secrets. Its structure tells us how it is made, how it functions, what mechanisms it uses when it infects, where and what changes so as to evolve and jump species. where it is weak, where it can be attacked. Specific medication has begun to be designed against viruses and based on their structure. A new form of fighting these agents has been born. Now everything seems to have been discovered. But no. With an electron microscope and a synchrotron, one can see through the atoms. But there is no technology capable of answering a basic question: knowing whether the viruses are alive or not. They might represent another form of life unknown to us. A different concept of life, bordering on the living and the inert. Viruses, and there is no way of understanding this, can be alive and dead at the same time. They're everywhere, on the crest of a wave, in the air, on the grass. They disappear and appear at full speed. The sun destroys them, and they're created again, millions in just 1 second. There are those who say that if we were to put all the viruses that exist end to end, they would form a long chain that would stretch to the ends of the known universe. In number, estimates talk of an unpronounceable figure, 10 to the power of 24. That's a 1 followed by 24 zeros for the viruses present on Earth. By looking for them in nature and isolating them, it has been possible to recognize and classify more than 2,000 different species of virus. This is what these researchers are dedicated to. They are virus hunters. They are looking for new viruses in the plants in a jungle and in the waters of a bay in the heart of civilization in California. The researchers might find a new species of virus in these samples, one not expected in this environment. Who knows? They are hidden among other matter. One has to filter and filter the water, dissolve the leaves until one can obtain a definitive sample. The time has come, and it has happened again. The 2 water and plant samples are full of viruses. To date, viruses have been found in all living beings analyzed.
There are more than 250,000 species of plants on the planet, and we have found that 6% of plants contain at least one type of virus. That is why we believe that more than 18,000 species of virus exist on the planet just in plants.
Here what you can see on the screen is from 1 drop of water we collected early this morning. And in one drop of water you see those little green dots. They are viruses in the water. There's millions of them in that single drop of water. The larger particles you're seeing here, they are bacteria. There are also many bacteria in the water, but in general, there's 10 times more viruses in every drop of water than bacteria in the water. Most of those viruses not causing human disease to our current knowledge, but they may evolve and then probably causing human problems in the future.
We don't know why they do it, nor what mechanism or conditions are required for a virus, whether in nature or in an animal, to decide to evolve, to change its habitat, and to jump from one species to another. But frequently, with every new leap, it forms a new virus, and a new disease appears. This can take centuries, or just a few years, or even months. Colin Parrish has witnessed the speed with which a virus has managed to escape and jump species.
This is the virus that we study, which is canine parvovirus, which in 1978 jumped from cats into dogs and created a new host range. And the changes that we see are also found in the same region. So the virus is gradually accumulating changes, and over time it's becoming better adapted to dogs.
Once it adapted to its new victim, the virus spread throughout the world in barely 6 months. A new disease and a new virus had appeared in the animal world. But who can say that it won't mutate one day and affect human beings?
Well, when you're out in Montana in the beautiful nature and fishing and looking at the birds and the animals and the cranes and things, a lot of times it's hard to remember that many of the infectious diseases which are emerging around the world today actually are coming from animals.
All the new diseases that have appeared over the last 10 years have been provoked by viruses. All of them viruses that have come from animals and that have evolved, crossed species, and now affect the human population. In parallel, many viruses that were confined to one part of the planet have spread to other continents by using animals and people as their means of transport. Faced with this threat, all research related to emerging diseases is carried out under strict safety measures. The scientist heading this line of research is Marshall Bloom. Marshall runs the Rocky Mountains Laboratory, a center set in the middle of nature and dedicated to researching new infectious agents from wild animals.
Since the mid-1970s, there have been over 24 new infections which have been described in human beings, which had never been previously heard of before.
They are in nature, seeking shelter in a wild animal that they don't harm. They use it as a host. It could be a mammal that migrates, or a bird that with every flight transports the viruses it carries within it. That is how viruses travel easily from one place to another on the planet. Wherever they arrive, they transmit themselves to humans through arthropods, mosquitoes, ticks. They can start an outbreak, an epidemic, or establish themselves forever. This is what happened with the West Nile virus, the trail of which is being followed by Marshall Bloom. This scientist is a great expert in fly fishing for trout. It is through this sport that he is in permanent contact with the nature in which the West Nile virus has found its own hiding place. Isolated in Uganda until barely 70 years ago, the virus came to the United States in 1999. It appeared suddenly, infecting birds in the New York Zoo.
Exactly how that virus got to the United States from the European continent and at the African continent isn't known, but it's here, and within a very short period of about 4 or 5 years, it swept across the entire United States.
In just a few months, it caused 700 deaths in the population. More of a traveler, and more widespread today, is one of the main viruses being studied in the Rocky Mountain Laboratory. The tick-borne virus that causes encephalitis in humans. It arrived in Europe and North America, one suspects, because of the climatic change that provoked a new global distribution of ticks, the vector that transmits it. The population is exposed to infection by this virus through contact with nature, with a simple stroll through the mountains, and develops neurological problems that can lead to Parkinson's and paralysis. Or dengue, the main viral disease transmitted by mosquitoes throughout the world. From Southeast Asia, where the virus emerged, it has gone on to infect populations in America, the Eastern Mediterranean, and the West Pacific. Today, the virus causes 50 million infections a year and lives permanently, is endemic, in 100 countries.
So the answer is yes, viruses which emerge into human populations from animal populations now are a very serious risk.
Despite nature's role as the main source for new viruses and in the emergence of natural epidemic outbreaks, international efforts against viruses appear to be focused on bioterrorism, on the possibility of a deliberate attack against the population using a virus as a biological weapon. There are hundreds of websites, guidelines, and manuals from health bodies, armies, and governments on how to act and what to do in the event of a bioterrorist attack. They reflect the fear of the appearance of a new disease, recalling the specters of those already experienced. Smallpox, the virus that caused, without the need for human intervention, some of the largest pandemics in all history, continues to be the most feared infectious agent.
Smallpox as a disease is certainly one that would be one of the most frightening in terms of its ability to both cause severe disease, severe fever, and disfiguring rash, as well as the opportunity of this agent to transmit between humans.
Since smallpox was eradicated thanks to the worldwide application of a vaccine, and as the virus has no hiding place in nature, an international agreement was reached to keep the virus frozen in two centers, the State Center for Virology Research in Russia and the CDC in Atlanta, where it is confined in the department coordinated by Inger Damon.
Well, I think certainly the hope is that nobody has it, but I think there are some concerns that other individuals may actually have the virus.
The suspicion is not just that other persons might hold the smallpox virus, but that they might be thinking of using it against the population. Is the person who has it in his custody really afraid that a bioterrorist attack might be being prepared?
I'm not sure I have enough knowledge to, be able to make a sensible statement about that. I think if the virus were ever released, it certainly would be something that we would want to be able to rapidly respond to, and I think that's prompted a lot of the concerns and a lot of the research and the work that's been done.
I think one of the most important things that people need to remember is what our director, Dr. Anthony Fauci, always says, is that really nature is the worst bioterrorist. And so although bioterrorism is one of the reasons that we have to worry about new infections, viruses or bacteria which pop up in places where they've never been before, it's probably in the long run maybe not going to be the most important thing to worry about. There are about close to a half a dozen or more reasons that new viruses emerge and cause infectious diseases. And we need to take all of those into account. That includes climate change, crowded populations, changes in human behavior, human food processing, international travel. Someone can get sick in Africa and be back in the United States or in Europe in less than a day. So there are a variety of reasons that we really, really need to worry about emerging viruses.
But international politics have not yet set as a priority the strengthening of vigilance and providing an urgent response to the increasingly more detectable appearance of new viruses. The World Health Organization, the body entrusted with this mission, recognizes that it does not have all the resources it needs to face up to the emerging diseases.
Is there adequate surveillance for new diseases? No, there's not. There are lots of gaps in our surveillance system. So in many places in the world, we really don't know what's going on. We'll only pick up an outbreak once it's grown to become a news story, become a local concern. The response is stretched thin and it can be overwhelmed. It needs to be stronger.
And faced with outbreaks like the Marburg virus in Angola and many others, whenever the viruses emerge in developing countries, the WHO has to rely on volunteers and NGOs to be able to eradicate them. That is the response, the international aid that many countries receive with the appearance of a new virus and with the constant presence of those already established. As Francisco Ayala recalls in his logic and philosophy classes, controlling viruses in developing countries is a question for humanity, and it is an urgent question.
Of course, protecting against infections in developing countries has two purposes. One of these, let's call it human generosity and compassion, is protecting people who do not have the economic resources to protect themselves. But there is another aspect, which is that these infections could become epidemics that spread throughout the world and come to us, which in other words is saying by protecting developing countries, we are protecting ourselves. And once again, this question of the investment made against bioterrorism, against terrorism in general, if this money were to be invested in controlling infectious diseases in Africa and in other developing countries, the benefits for mankind would be higher, even for ourselves.
At this very moment, there are thousands of viruses evolving. At this very moment, there are thousands of viruses crossing between species, opening up roots. These may be in Asia, or they may be in the great cradle for practically all viruses, Africa. There is no clear theory, although there are some pointers that can explain this phenomenon. Why is Africa the cradle for so many viruses? This is the question posed many times by Luis Villarreal when he's thinking, writing, and researching on how viruses change and adapt themselves to new species.
My view on that is a lot of the capacity of agents to emerge in Africa has to do with the evolution of our own species in Africa and our relatives, such as the monkeys and the African primates. There are 40 species of African monkey, for example. Each one of them is harboring its own particular kind of viruses, usually in inapparent states. They just function as a good stepping stone for agents to evolve and make their way into the human population.
Viruses reach this village, where there is no drinking water, but there is permanent diarrhea, malnutrition, poor health infrastructures, and illnesses such as malaria.
We now have, in sub-Saharan Africa, a huge population of people that are immune suppressed. And an immune suppressed population is just a much easier stepping stone for an agent to adapt and to become capable of transmitting in a new host such as a human.
This is what happened with a virus that has already affected 25% of the population of Black Africa. This is the human immunodeficiency virus. It causes AIDS, the illness suffered by Safina. She's 26 years old. Around her reigns the most absolute silence. That's what she's requested. Safina is bidding farewell to life on one day at the end of November. It is thought that the human immunodeficiency virus crossed from monkeys to humans close to this immense lake, Lake Victoria. It is one of the sources of the Nile River. Paradoxically, or perhaps with enormous significance, it is from this same environment, the cradle of mankind's evolution, that also emerged the West Nile, the Epstein-Barr, the Semliki forest, the Ebola, and the Marburg viruses. And the viruses from the Bunyaviridae genus, a large and diverse group of viruses that produces serious infections, were isolated barely a few kilometers from Bundigbuyo, from the village of the Association of AIDS Widows. 53 women whose determination to survive has kept them united. Today, they have an important meeting. Someone is going to call a meeting of everyone in the village. Following behind them are the children, other women, the elderly, who here in sub-Saharan Africa are no older than 47. This is the life expectation imposed by the human immunodeficiency virus. They are making for a small room barely 6 meters square, which they use as headquarters. They have lost their husbands and children to AIDS. And these other widows bear the burden of the lives of more than 180 orphans. Dragging the timidity of one who is asking, and with the imperious need to ask, the AIDS widows raise their signs. A virus is killing us. Here is Safina's mother. But they are also asking for financial help. And they have no transportation, no houses, no food nor medicines for the orphans, nor so many other things. All because of a virus. But is it just the fault of a virus? Only a virus? The AIDS widows talk.
We kindly request the government of Spain, NGOs, the individuals of Spain to come to our rescue before we die. Thank you.
Threshing the earth, leaping between species, hidden in nature, or laying low in our own bodies, active and inert at the same time. Millions and millions of beings that surround us and invade us. They're everywhere. But what kind of life? A human being with a human being. An animal and a human being. An animal and a plant. Maybe two animals, maybe two plants. They rub. They get close. In each meeting, life is transmitted.